So thank you. First, I would like to thank you to invite me to this event. So it is my second event. You remember me that I was in Lugano some time ago. And I would like also to thank you, Posi, for hosting this good event. I really like this country. I really like the regions. Even if I must confess that I'm totally jet lagged. Because for those that are still wondering where my beautiful accent is coming from, I'm French and I'm living in France. So my name is Marc Simon, and I'm a part of Atos group in the big data organizations, and I'm the leader of the HPC pre-sales team. And I would like to share with you in my presentation some thinking about Exascales first, before talking about some European initiative to support Exascale, and finally how all this change in the world of HPC is driving our R&D to develop systems and to develop new technologies for the Exascale. So first, I think this part will be fast, because in fact we have already heard a lot of talk about what has changed recently and what is exaflops, and why we are not talking anymore about exaflops but more about Exascales. But I would like first to cover, if you well remember, for those that were in this market some time ago, in June 28, we had the first petaflop systems available, the Roadrunner systems, IBM systems, that reached for the first time this level of performance. At that time, it was a great achievement, and there are some predictions from the top 500 teams that the next step, which is exaflops, will be reached in 10 or 11 years. In 10 years after, in fact, IBM again with the Summit project reached 122 petaflops. So, in fact, the road to exaflop is longer than expected. We know that during this period, a lot of things have changed in the microprocessor. This slide, you have seen exactly the same in the Xenon presentation, so it's well used and explain a lot of things to understand, in fact, what happens. Number, of course, was critical to have more performance. So what happens to, I would say, to the end user, to developers, to researchers? So vendors like me say, okay guys, now there's no more free lunch. You not just have to wait for the next generation of Intel processor with the clock speed increase, etc., to have more performance. You will need to think about parallelism. So you will need to extract some parallelism from your applications. You will need also to try to vectorize more. So, okay, so it is a way to go. Unfortunately, I would say some years after, the same customer come back to us and say, okay guys, I've done everything you have mentioned. So now I have a new computer, and guess what? My application is not running so fast on this new computer compared to the previous one. Yeah, you know, it's technology are not evolving all at the same speed. And what happens during this period, if you could see in the graph, is that the ratio of evolutions between flops and memory speed, memory latency, network speed, and network latency is totally different. Meaning that today we are, with this type of technology, we are more and more often memory bandwidth limited or network latency limited as well. And guess what? Now we are not talking only about flops, because we have flops and flops. So in 2008, nobody was asking what was the precision of a flops. By default, it was double precisions. Today, we have reduced precisions possible, and we have new instruction set like the B16 that could provide you at least the same dynamic range as a FP32. So it means that now a flop could be a smaller flop, but at least it will provide you at least 4 times the speed of a FP64. And even with special instruction for machine learning, like the one that has been implemented by NVIDIA, you could have a mix of precisions in your operations. So meaning that you could also increase the level of number of flops you could do in a cycle. So yeah, a lot of things are changing. And the reason for things are changing is that during the same period, everybody needs to change the technology and needs to change their software. So if they need to integrate new technology, to have their software to be updated, so it was also a possibility to include new way of doing things, thinking differently. So yes, AI is clearly a key driver during this period. This is why also for us, we consider that Exascale is not only exaflops, it's a new way also of doing computing. Because we will have new usage. So it means that in terms of usage, we need to have a convergence in terms of infrastructure. We need to have all the benefits of decades of knowledge in the HPC industry and how to optimize and how to be very efficient for large-scale computings. But we need to also to handle new paradigm for big data and AI workloads. We need to take care of data deluge. We know that now applications are more and more data-centric. So yeah, we have to consider that also in the way we design our computers. And the type of usage, we are talking a lot about cloud, private and public clouds. And yeah, we need to find a way to facilitate the access to this type of technology and let the researcher, the end user, use what is the best for him without reprogramming everything, because as it was mentioned earlier, the software stack is becoming more and more complex in time to times. Just a few words about new usage. We think about the digital twins. Digital twins is a perfect example of combinations of many different type of technologies. A digital twin of an aircraft, an airplane like this one. This is a coupling of data collections, analysis, and multiphysics simulations. So during all the life of the real airplane, you will have a digital twin that is able, in fact, to ingest all the data collected from the real airplanes to simulate what is behaving correctly or not in the airplane. So yeah, perfect combination of new usage for the Exascale era. And of course, precise medicine, so digital twin or digitally supported human. So we will have probably in the future prevention and prediction of disease and conditions, meaning that you will have a personalized medicines dedicated only to you and not to the others. Data deluge, yeah, HPC needs to be much more flexible and agile and be part of, I would say, a loop or a network of devices connected all together, solving a part of the same problems. With edge computing, we need to provide more, I would say, capability at the source of the data to extract some insight before moving the data to a more central point for the HPC. And in these cycles, you will place the HPC correctly in the loop now. So I would like, as an introduction, to mention that I'm not personally a specialist of European initiative. It took me, I would say, a few hours just to understand exactly the different type of acronym and how it is managed or handled. So for those of you that are not very aware of all this initiative, I would say that at least since a year now, we have a kind of umbrella that is a EuroHPC acronym, which has, in fact, is supporting all the initiative, the European initiative regarding HPC applications, HPC research infrastructure, and HPC technology also in supply chain. Meaning that there is plenty of projects, plenty of organizations that are all now focused to different objectives, but everything regarding the HPC. I will just mention a few of them and few examples because I think it covers almost all the needs we need to reach Exascale in Europe, at least for European applications. The first one regarding EU collaborative project through the Horizon 2020 project. You have many centers of excellence in different areas. So I've mentioned only ESCAPE and Easy Waste here in the climate and weather forecast, Compiomed also, and you have few others areas where we know now that we need to be prepared for Exascale. It means that we know that we have to collaborate with vendors, with experts, with people that are developing applications to be ready, in fact, when the Exascale systems will be available. Evolution of code, performance portability are key, but also, I would say more vertical or horizontal, depending on the way you look at it, but on the tools. You need to, when you have 1,100 of cores that are running the same applications, what are the tools that will be able to debug or at least to profile, to instrument such things without perturbation to the rest of the systems? So yeah, a lot of efforts are done on this area, and I think it is very valuable for all these communities and for the software ecosystem around HPC as well. I'm sure that everybody heard about EPI, the European Processor Initiative. It has been launched 1 year ago and finally officially launched at the end of last year. It's a long-term initiative around the capability for Europe to be more independent of such important technologies that are processor, accelerators, and networking technologies. So first, the EPI, European Processor Initiative, will focus its effort on a general purpose processor that will not be dedicated only to HPC. The market is far too small, but also for the embedded market. So it means that since the beginning, this is totally a new approach of designing processors. So it will be completely modular, based on chiplets and common platforms, EPI common platforms, where in fact you could put different type of chiplet working all together to solve your problem, depending in fact of type of problems you may have. So the roadmap is very aggressive. 2021 for the first generation. It will be a combination of ARM and RISC-V processors. So you will say ARM is not totally European, not anymore, in fact. And yeah, that's true. But it was not the case when the project has started. So, and yeah, so it's really a question of sovereignty to try to be able to be more independent in our changing world, where we all know that everything could change with a single tweet. So yeah, we need to be prepared to that. So the interesting processor for us, at least for Atos, because Atos is part of the EPI project, but me personally, as a pre-sales, I'm more interested in what I could sell to you. And it will be around 2022, 2023. It will be the Gen 2 of this general purpose processor, where we are considering that it probably will be the vehicle for the first exaflop systems that will be available in Europe. Another project, this one personally, for me as a pre-sales, is very interesting. It is an effort between 5 leading European supercomputing centers. So you have the logo, BSC, Barcelona Supercomputer, the CEA, Cineca, GenC, and ULISH. They have all worked together to define coordinated roadmaps. To select, you have seen 7 points of interest, of innovations they would like to see in all their new procurements that will arrive, that are arriving or will arrive in the future, with different type of objectives, what they call features. A features is something that by default you need to have when you propose a system to this guy. Objectives are, I would say, more long term. It means that during the life of the installation of the project, you will need to reach this level of features. And the last one is goals. So even after, for the next generation, what they are looking for. So for us, as a company developing hardware and software, it's a perfect roadmap. We know where they are going, and it's perfect to see where we have to put our money and where we have to put our efforts, because we know that it will be of interest of most of the biggest centers in Europe. Last but not least, the most recent European initiative through the EuroHPC World-Class Supercomputer Project. The joint undertaking has selected 8 hosting entities, 8 hosting sites, 3 to host pre-Exascale systems, they call precursor to Exascale, and 5 for petascale systems. So the participation of the different members of EuroHPC was quite huge, 19 above 28 countries. So when you have to play with a project with so much participants, it's it's a challenge. You could see that you have big names again. So BSC, Cineca, and CSC has been selected to host the pre-Exascale systems with different type of partners. The list of partners could change. It's still open up until the end of the month, I think. And probably that Netherlands will join also the CSC project. And you could see also that some countries that are not well equipped today in Europe, for those that know the European HPC ecosystem, like Bulgaria and Slovenia, they will have also petascale systems. Luxembourg will start from almost nothing also, and will have a big one. In fact, we are talking about between around 10 to 20 petaflops for such systems in the petascales. And we are talking about 150 petaflops for the 3 main sites. The objective is 2020. They are targeting 2020, meaning that probably it will be 2021. And it's a huge investment, but it's co-investment, meaning that it's different from probably from the US, from Japanese, and from Japan, sorry, and from China. It will be very open. They would like to, they will require diversity, so they don't want to see only one vendor, even if it is a European one. It is a co-investment, meaning that EU will finance between 30 and 50% of this amount, and the country needs to fill the gap. So what does it mean for us in terms of Atos regarding the Exascale? Looking at what we have presented earlier, and knowing also that we are very new compared to big ones that are in this room also. In the HPC market, we are a teenager, I would say. The first system has been proposed in 2006, so yeah, we are still teenagers. We are learning fast, and we have the agility, in fact, to develop and to adapt to new technologies. So for us, we consider that there is 5 areas of interest where we need to, in fact, to invest. We have already done. But this is a focus for the years to come. So in terms of technologies, to reach Exascale, we consider that we have introduced today our last generation of supercomputer called the Bull Sequana XH2000, with first installation last quarter. And we consider that this platform will stay for a long time. Why? Because it is already very, very flexible and very open. So we have already a large choice of capabilities for hosting computing power in it. So with Intel, with NVIDIA, Marvell, AMD, Xilinx, and also a large choice of interconnect, BXI, Mellanox, and we have a high-speed Ethernet with Mellanox as well in it. And in terms of platform, it is already very efficient. So in a single rack, you have up to 96 compute. You have your power, you have your network, you have your high-speed network, and you have your cooling. Everything in a single rack. So when new technology will be introduced in 2020, 2021, we could very rapidly develop the blades to be integrated in this environment. And in the software, this is a parallel initiative we have. We are working on next generation of software management, yes, to take care of what we have said during the 2 days. The fact that now, in fact, we need to consider that HPC is not a standalone system, but needs to live in different ways, with different other workflows. Taking a look at the processors, we are part of the API, but we are looking, in fact, to define what is a kind of ideal HPC unit. We consider that in the future, the best way to do things will be to have heterogeneous core and not heterogeneous systems. So it means that at the core level, in fact, we will have differences depending on what is running on the systems. We consider also that we need to be able to manage very high TDP. So we are seeing already some partners that are giving us more than 800 watts for systems that will arrive. And for us, key elements will be to be able to target the 1-to-1 ratio between bytes and flop, or flops and bytes. But if it is 1-to-1, don't care. So when we are saying that we would like to see that, this is also what we would like to see in real processors like the API initiative. On data management, it's not new things, but in fact, what is new in the way we know that for different space, because we have different needs, so we have different level of storage. And consider that we will continue to have a mix of all this type of technology. And what will be key, this is in the center of the slide, this is the storage management, the metadata management, how you could automate movement of data between all the different levels or tiers, even if I prefer levels. And this is an area of interest for us since many years. And we have initiative also to work on solutions to automate a lot of things. In terms of networking, we have started the development some years ago about the Bull Exascale interconnect. And in the name, you see that we are targeting Exascale with this interconnect. That's why also we are still at the V1 version of this product that is available at customer site since a year now. And we will have a V2 update next year, where we will see a lot of improvement, especially on the software side, because network is not only about hardware, but it's mainly about software. So we are working on new routing algorithm. We are working on supporting a new type of workflow. And the idea is to continue to develop things that will be needed for exascale systems. So we are targeting, again, 22, 23. In terms of energy, I would say that we have almost checked the box. We consider that today with the Bull Sequana XH2000, we are at the top of what could be done with direct liquid cooling. This system is totally fanless, very quiet system. Everything is water-cooled and could be warm water-cooled. We are very flexible for the water cooling for people that are moving from, I would say, current data centers, and they know that during the life of the system, they will change the cooling system to be more efficient. It's not a problem for us. We could start from 6 degree inlet to up to 40 degree inlet. So the only thing that is not water-cooled is a pump of the hydraulic chassis, the heat exchangers that are at the bottom of the rack, meaning that we are able, in fact, to manage 95% of the energy we dissipated in warm water, up to 40 degrees. So when we are comparing to competitions, yes, of course, we are very efficient for compute nodes, CPU, memory, GPU, but also the high-speed interconnect from Mellanox or BXI is water-cooled. The management network internal to the rack is water-cooled, and the power supply units also are water-cooled. So in the future, we plan to increase a little bit the inlet temperature to 45 degrees and reach the 98% efficiency. The last but not least is applications. So before talking about collaboration and applications, we need to have tools. So we are completely refreshing our software ecosystems. First, I would say management stack will be a unified user experience between traditional HPC and traditional AI and cloud workflow. So today we have two tools, the Bull supercomputing stack, and the second one is Atos Codex AI orchestrator. The Codex AI, in fact, is able to, as an orchestrator, to manage a different type of workload for HPC and for AI. And in the future, everything will be unified. We have a few, there is only a few tools that are mentioned here, but regarding energy optimization, one is very interesting. This is a BDPO. It's transparently taking care of your application and reduce the power consumption of your application without reducing too much the time to solution of your applications. So as an example, we have in real productions ocean modeling using NEMO. And with NEMO on 128 nodes, we are able on Intel processors to reduce the power consumptions by 18%, 18%, and increasing the time to solution of only 3%. So this is really key examples saying why we could be very energy efficient. It is even better if we consume less than expected for typical workload. And on the I/O side, we are at the phase 2 of this smart I/O management. We have introduced first the I/O instrumentation, so we are doing a lot of very low-level I/O instrumentations, collecting tons of data, and imagine what? We are putting some AI on top of it to determine if there is possibility, in fact, to accelerate this I/O. And use two types of accelerator today we have. The first one is a fast I/O library, and a second one is a smart burst buffer. So yeah, this is typically activities where we are concentrating our R&D for the moment. And as I mentioned, we consider that collaborations with community are key. Because in fact, we need to be sure that everything works well to be part, in fact, of the development or optimizations, or to see what is happening, and to understand also why they would like to have AI in their workflow, how it could be implemented in the best way. So we have a large team becoming larger and larger that are part of a Center for Excellence in Performance Programming. Sorry, it was parallel in the future, it's performance now. And this team participate to some of these projects that are mentioned, but also are creating a new Center of Excellence. And we have a new one that has just been announced 2 days or 3 days ago in India with the CDAC that have signed the development of a Center of Excellence for quantum programming. And so it's part of our strategy also to offer that. And we will collaborate also with the CDAC and Exascale Technology like processor and like interconnect. India is, I would say, in the same position as Europe, in the middle between China and the US. They would like to have some kind of independence in terms of key technology for the future. So in summary, yeah, we are very young, as I mentioned, so we are working on few areas. We are feeling that we are doing well, but we need your help. We need to understand more what are clearly your pain points. Coming back to the PPI for HPC initiative, where in fact big centers are okay to say, okay, we would like you to focus in this area, in this area, in this area, and our priority in terms of time is this and this. For us, it's crucial. Everything is changing, technology are arriving very fast. We are talking about new type of accelerators in many ways. Yeah, we will have to make choice, and to do that, we need your help also. I think I'm done, and I think I'm late. Yeah. So.